All right. Hello, everyone. I'm Matt Parsons, the head of defense for AgEagle. I'd like to once again thank you for joining us today for an operational presentation of the eBee Vision and online webinar. I'd just like to thank marketing for their time to put this together once again. We're going to be talking about some of basically just the baseline operational characteristics of the eBee Vision. I'm also going to include some recent feedback and stuff that we've gathered from tests that I've done here at the National Training Center this week. And then past week, we did some nighttime operational training for some of our vendors and partners. So once again, I'm Matthew Parsons, the head of defense for AgEagle Aerial Systems. You're going to see Jean-Christophe, the head of GNC Aerodynamics, in a little bit later presentation where he'll go over a complete overview of the system. He'll do some flights. He's going to talk about the flight modes and do assembly, disassembly, and just some of the baseline operation characteristics that you can perform with the eBee Vision in a tactical scenario. Before we begin, so you have a question and answer tool that you can submit to. Additionally, after this webinar, you're going to be sent the webinar recording and a PDF copy of the slides as well. So AgEagle. So we offer solutions in 3 verticals. We offer eBee ATAK and eBee Vision for our ISR and mapping topographic collection platforms. We offer sensors for geospatial intelligence gathering, or just baseline geospatial data. We also offer software in the flight control and flight management realms. Our flight control software is just very renowned for being very easy to use for the end user to be able to employ the aircraft quickly and get it in the air. And then our drone solutions and sensors, are world renowned for capability, clarity, safety, and operations over people. So what is the eBee Vision? What are we here to talk about? So the eBee Vision is going to provide real-time situational awareness, right? So it's meant to enable public safety, law enforcement, FedCiv type folks, and then obviously our defense-oriented customers, the ability to collect data where they might not be able normally to do so. And how we do that is make this platform extremely easy to use by the tactical operator or the public safety FedCiv operator to be able to get it into the air quickly. It's a safe platform to operate. And then they're going to be able to start gathering that intelligence data that they would not normally be able to at their level. So how we got here. So, 2009, SenseFly had the swinglet cam, which is just a very small styrofoam platform with a camera basically mounted to it, and we have progressed through the years to the eBee ATAK and the eBee X, which was our mainstay topographic data collection platform. And once we got into the DoD realm with the eBee ATAK, we saw that there was a small gap in the medium reconnaissance range aircraft area, and that's when we decided to develop the eBee Vision platform, which is meant to fulfill that medium range reconnaissance role in the battalion and below level echelon for DoD, and then also law enforcement and FedCiv agencies as well. So some of the pillars that eBee Vision is built around and AgEagle focuses on is, we keep our things lightweight. That increases flight time and duration to the end user. It's extremely portable. We're going to make them rugged so they can endure austere environments reliably. One operator, because it's going to take people to use this system, and we don't want that to have to take multiple or more than one. We're going to be NDAA compliant and always focus on cybersecure. So if we're operating once again in those austere environments or conflicted areas, the data is going to be protected, at least to the NDAA's compliancy standards. Quick setup, and then once again, ease of use. And then for the FedCiv and public safety sides, once again, focusing on safety over people, to where if this aircraft potentially does have an error or something like that, it's not going to cause a tremendous amount of damage or injury. So some more baseline characteristics about the eBee Vision itself. Once again, keeping in line with the pillars that AgEagle focuses on. It's 3.5 pounds or 1.6 kilos. You can deploy it in up to 3 minutes. You're going to get about 90 minutes of flight time. And then your extended range antenna capability is going to be able to give you up to 12 miles to 20 kilometers of range. Once again, it's validated as cybersecurity as the baseline AES-256 encryption. You do have the ability to suppress the drone logs, and it's a protected encrypted SD card. So here's our ground control station that operates the eBee Vision. This was built in conjunction and developed with the SROC DIU program. So it's an Android-based tablet, right? So when we're talking defense-oriented products, we have to be reminded of the fact that the average age of the end user is going to be from about 18 to 24 years old. they've grown up with this technology basically their entire lives, and this system is going to be very familiar with them to be able to use quickly. It's not going to be anything that they would have to be trained on extensive periods of time. And once again, we developed the controller to have that ease of use in mind. So the entire left side is all aircraft inputs. The entire right side is all for the sensor. And then your map planning software that's embedded into the ground control station is Mapbox background, and very Android click-based, mission profile building, to where I drop waypoints, or I can determine POIs either with MGRS grid coordinates, or I can manually define them if I need to fly in that area. All of your telemetry ribbon above is also color-coded once again to make it ease of use, so you can kind of get that route memorization built in of, green means aircraft, or, blue means while it's flying, and then yellow is target area, and those types of things. It's also interesting to note that all of the buttons can be pushed to operate the same controls that you can also manually touch on the screen itself. So it's kind of a redundancy system built in there. So now what we're going to do is watch Jean-Christophe go through about a 30-minute presentation of basically assembling the aircraft. He's going to talk about the flight modes, some of the things that you can do while you're in those flight modes, build out a mission profile. You'll see some assembly, disassembly, and takeoff and landing. Without further ado, please enjoy this video.
Hello, this is JC from AgEagle, and today we're gonna fly with the eBee Vision. But first thing first, let's unpack. So first, I remove the wing compartment. Let's put them here, and now we just open the main compartment where the drone is. So I always start with the radio. So today we are not going to go far, so we'll go with a small range antennas. So always put the antennas before turning on the radio. Let's do the other one. Okay. And now we just put the battery with the twist lock mechanism. Make sure it's secure here with the secure pin, and we can turn it on. We get the red LED, and it can goes on for a full day with one battery. So it's probably gonna hold for a while. Now let's take out the eBee Vision. We just need to open the battery cover, take one battery. So just put the lid up, and then just slide the battery in, and then secure it with the handle. And now we can close it, and with a long press we can turn on the drone. Now we can focus on the rest, so let's turn the GCS on. Okay, and now we have time to take out the wings. So to plug the wings, it's extremely easy. You just need to align them and push, and that's it. And the only thing we need to make sure is that nothing is preventing the control surfaces from moving. So now we can just let the drone sit next to us and plug the radio into the GCS. So it's just sliding it in. And here we can see on the screen that we have the double arrows. That means that everything is plugged correctly. So now I'm just going to launch the app. Okay, so now as we can see, the LED is green, so we are ready to take off. So if I just press fly, here we have the default flight plan, and we could go. For today, I've prepared the flight plan so we don't fly over people's house. So let's do this instead. So I just go in plan, And here I can load my flight plan. And just selecting it, press open. And now we have our 5 waypoint flight plan. And we can check the altitude of every waypoint. And we also have 3 points of interest that I have put on the map that we can check later on. So before we go, we should check the setting and make sure that everything is correct. So here in the interface, we could change the units, but it's not what we are interested in today. So let's check the flight. So here we use AMSL altitude, which means the drone will keep a constant altitude at all time, which is better if you want to avoid altitude changes, which mean more noise. So like this, it's stealthier. Then we'll have the loop flight plan, which I like, and that the rest of the options are okay. And now if we go into the safety, we can see we have a 3-kilometer radius, 750 meter altitude. The most important setting would be that the altitude referential for the return to home is AED, so which means the drone will use the elevation data to go home and will keep all the safety on. But we could, by a single press, turn them on or off if we want to. So now let's go back into to our flight plan. We can check the elevation by doing this. So now we see the ground is approximately at 600 meters. We are going to operate at 720. So it's legal. Here we can see the ceiling is maybe a bit low. So let's add, we've had 30 meters more. So now we're safe and we can go. So we just press play here. And now we are on the flight menu and we are ready for takeoff. So let's take off. For the takeoff, the first thing is just check the wind direction. So you just do like this. So the wind is coming here. So I'm going to launch in that direction. So I just put my back against the launch direction, hold my drone like this, and perform the shake. So here I make sure the control surfaces are moving. The gimbal is calibrating. And once the calibration is over, I'm ready for takeoff. So now we did take off and the drone is just on hold above us, waiting for us to tell it what to do. So if we look at the screen, we see what we call the map view. And if I zoom, we can see here the eBee vision performing the hold pattern. So let's take a few minutes to go through the interface. So the map view is really meant to get an overall view of the mission. And generally, when you are operated, you should not use it too much. And as we will see, we put a lot of effort, so you can do everything from the video view. But today, we will probably switch a lot so we can get a better understanding of what's happening. So let's start with the upper part, which we call the telemetry ribbon. In green, we have the information that is related to the battery levels, the link quality, and also the number of satellites that we see. Then in blue, we have all the information related to the drone itself. So we have the coordinate of the drone, the azimuth, the distance between the drone and myself, the 2 altitudes that we may use, the wind speed, and the ground speed. And then on the side, we have in yellow everything that is related to the target. So currently nothing is displayed because the gimbal is not deployed. That also explains why we get a black screen for the video. And the last part is the flight time and also the local time. Another important point is on the everything has been thought so that all the camera function are on the right side and all the drone function on the left side, and like this you can use this to find the function wherever they are. The final and probably most important information is what we see at the bottom of the screen, which we call the status bar. So here it's telling me my eBee vision is on hold and that my gimbal is retracted. So now let's start the mission and let's go through the different functions together. So here I will remove the dead man switch. Okay, and now I'm good to go. So with this button, as you can see, I can circle between the different waypoints. It becomes white. So we go waypoint 1, activate go. And now my eBee vision is in flight plan and the gimbal is being deployed. So from this, we can check the altitude by just pressing the secondary drone control joystick. We see that we are now at 120-meter altitude, and we will stay at this altitude for as long as the flight plan is going. And now we switch to the video view. So now what we see is the RGB camera. So I can use my right joystick to move it around. And as we can see, the gimbal, it's currently moving with the drone. This is what we call unlocked mode. So we can see it in the status bar. And if I just press the hold button here on the right side, we can lock. And now if we zoom on this block, we see that it's now always pointing at this intersection. And then we can go back. And if we press again, we can unlock, and it's now moving again freely, which is extremely useful to get familiar with the environment and get to know the surroundings of the mission. Another thing that we can do during the flight plan is check the various locations that I have marked. So here we'll switch back to the view, map view, and you can see I've marked 3 points of interest. The closest one would be the point 3. So let's select it. So as for the waypoint, this time I use my right hand. You can see I can cycle between the POIs. So now we select 3, we activate it, and now if we go back into the video view, we can see that the gimbal is pointing at the POI 3. So here we can zoom on the building, and we can see that the camera switch will occur around 5 times zoom. Now we are just on the teleobjective. So here we get a nice footage, and if we zoom completely, we can see the level of details that we get. Here, if we look at the right upper right corner, we see at around 200 meters from the parking space, getting further away, and this is full zoom. So now let's zoom out. We can also switch POI. So let's check the second location here in the forest. And now we'll use the thermal camera. So I press the thermal cycling button with my right hand again. And here we now have the thermal image of this small lake. If we zoom in, let's see if we find something interesting today. So not much to be seen, unfortunately. So let's zoom out. So here, this is currently the whiteout. We also have the blackout setting. And let's unlock and try to see. We can look below us on the forest. So if we zoom in, we see that we could easily spot if there are some people or animals here inside the forest. And again, at any time, I can just lock, and the gimbal will maintain in sight what we are filming. And if I press it again, we'll go, and here we are back on RGB, and as we can see, we are still locked. I unlock, fully unzoom, and we are back on our original mission. Last important stuff that we could do during the flight plan is to retract the payload. So I just, again, with a single press, we are retracting, and we are now in what we called the transit mode. So during the transit mode, the payload is up inside the drone body, so we get low stabilization as it's mostly locked into the drone, but like this we maintain a certain amount of visibility of what's happening below us, and we reduce drag, so that will be extremely useful if you have to fly a long distance. You can do this and gain some precious flight time. And again, if I just by a single press, we will deploy the gimbal again, and we'll see it's going to come back, and now we are deployed and unlock again. Now what we are going to do is we are going to use scooting mode, which is again accessed by a single press on the right hand, and here we'll try to follow this car. So as we can see, I just need to follow it with my joystick, and the eBee vision will follow it. Now we see this car is pretty fast, so if I press the fast mode on the drone side, which is left side, we can see now it's fast mode. If we look at the ground speed, we are now going full speed, and like this I can keep track with this guy even though it's going quite fast. And like this we could go for a long time and follow him. So let's stop before we go over the village. But you get the idea. The scooting mode makes it extremely easy to follow a car. Let's try to focus on this one. So again here, what we need to do is just follow the car with the joystick, and the eBee vision will do the rest, and it will just follow the road and go wherever I'm looking at. If we go into the map view, let's point at something. So here, if I'm pointing at this road intersection, okay? If we go into the map view, now we see that we have a circle. So this is where the eBee vision is going to go, and is going to circle here. So it's extremely easy to use this feature if you need to go somewhere or just follow a moving target. That's probably your best choice. So that would be the basic feature for the scooting mode. Another cool trick that we can do in scooting is I've marked a few locations on the map. So if we see the POI 1, let's say I want to go here. So again, I circle between the POI, I activate it, and now we see that the eBee vision is going to fly and make a circle around this location. So ideally, you would do this without going into the map view, but for today's, we'll go and make a few changes, so it's easier to get a feeling on what's happening. So now we are going to take picture of this building. So first, I switch into the picture mode, which you can see here on the bottom of the screen. And now with my finger, I will just trigger some picture of this building. So we'll try to make a few photos. So here we can see we are 250 meters from the building, which is probably so far so they will never hear us. And by using the scooting, we can make a 360 turn, and later on we could use this picture to put them in an app like Farsight and get a 3D reconstruction, which can be very useful to get a fast mapping information. One another extremely useful feature is the gallery button. So here on the upper right corner, you can see the gallery button. So if I click here, we can see the last picture I've taken at full resolution. So if I zoom in, I can really check the quality of my image. And as you can see, we also have the GPS time and the coordinate of the image. And like this, I can make sure that the picture I've taken are good enough. Let's go back to the map view. So when we are in scouting mode, there are a few advanced features that we can use. The first one is we can adjust the distance between the target and us with what we call the distance joystick, which is on the drone side. So here, as you can see on the map, I can choose to make the circle bigger or smaller. So like this, I can adjust the distance to my target. I can also change the direction. So now we are blinded by the trees. So if I just want to turn in the opposite direction, I go on the side with the secondary drone control joystick, and we can see on the map, the eBee vision is going to make a half turn. And like this, we avoid spending too much time behind trees, and we can maintain the visibility on the building. So let's switch back to the video view. So here, I've triggered it a bit late, but we'll do it again to get a nice demo. And we'll use this time, this second passage, to take more pictures of the building. Okay, so now we're good. Let's take a picture. Another thing we can do is we can use the secondary drone control joystick to check the altitude, but also to change it. If I press it up or down, I can reduce or increase the altitude of 20 meters. This is always available in all the flight modes, and it's extremely useful if you want to change to get closer or further from what you are filming. So let's wait until we reach the trees at the beginning of the forest. So now, as we can see, I'm going to be blinded by the trees again. So I just press the secondary drone control joystick on the side, and we will see the eBee vision will perform a half turn. Okay, so now it's happening. And now we are going the other way around, and like this, we can maintain the building inside forever, which is extremely useful. So it's one cool trick we can do with the scouting. So now that we've done some scouting, let's use the secondary main mode, which would be the observe mode. So here, again, with a single press, we can see on the status bar that we are now in observe mode. And if we go into the map view, we see that the map is now showing the observation waypoint and the square what the eBee vision will operate to point at the POI one. So observe mode, it's meant to look at an object from a distance without getting too close. So now the eBee vision will perform some circles inside the area that is displayed as a square here to give me maximum visibility of this building without circling it. Here we have some people walking around, which here we can see a demonstration of the zoom capacities. So this is full zoom, and as we can see, we are around 700 meters from them. So that gives a good idea of what we can see. So let's unzoom and focus on our building again. So we are pointing on the building one. Here we get some obstruction. It's because we are on the wide angle camera. So we can see the wings and the body, but as soon as we zoom and we go on the teleobjective, we'll see that we get a nice footage and we don't see the wings anymore. So here we are a bit far away from the building. We get the forest, so we probably want to change. So again, let's switch to the map. So here something interesting has happened. As you can see, the flight space has changed. This is because the eBee vision it's optimizing the trajectory based on wind. Since wind is higher, it now switch to this shape instead of the previous one to give me a good visibility. I can again use the secondary drone control joystick to do some advanced tricks. So here, let's say we want to see the other side of the building. I can just rotate my trajectory. Here you can see that the eBee vision did adjust the flight path based on the new observation condition. And now we get a nice view of the building. So let's go here in video mode and press record. So now we are recording the building. We can zoom out, zoom in. On the video, we also can adjust the contrast with the image setting, so it can be brighter or just a bit darker. Okay, so like this you can adjust as you want. We can switch to the thermal view. So here we can see the people walking by. Okay, so this is the distance. It's almost, we can see 700 meters, and we can easily spot people on the road. So that shows the capability of the eBee vision. So let's go back to the RGB camera. So in Observe, I can also adjust the distance to my target. So like this, we can see I can go further or closer to my target. And you see, as I move the observation point, the trajectory is being adjusted by the eBee vision. Another stuff we can do is we can switch POI. So let's check the location 2. We can see that nothing is happening at the lake. Let's go back to check the main building. So we are not just behind the wing, but if we wait, we'll see. So we can switch. We can easily switch from the building to the small lake with a single click. So we can observe both locations at the same time, which is extremely useful. So let's unzoom completely. And then now we've seen what we can do in Observe. We can also just use our finger on the map to move the observation waypoint. And that's also convenient. So now we've covered the Observe mode. We can activate the flight plan again by just pressing Go. And the eBee vision is now going to the waypoint 1. Let's unlock the gimbal and we'll go on the flight path. So the first flight mode that we did not test today is the manual mode. So here I can take manual control of my eBee vision. It can be useful if I want to navigate by sight or if I get GNSS jammed. So if I lose my GNSS, I can still fly my eBee vision in manual mode. So to do this, I just use my left hand. So we can, on the drone side, I press manual. Now we can see the eBee vision is flying in manual mode and the gimbal is facing forward. So this is used so the pilot does not get confused. So it's always looking further. And here I use this time the drone control joystick to just move around. So it's extremely easy. So I can just turn. We can also go up or down. So now we are going down so that we see the nose a bit. And it's extremely simple. So we could use this to just navigate and go somewhere. If we go into the thermal view, it's extremely useful to just look around and find some points of interest on the map. So the main difference between the manual mode and the scouting mode, in manual mode, the camera is looking forward and we are piloting the drone. If we go in scouting mode, we are actually piloting with the camera, so it happens with the right hand. And when the drone reaches the place we are looking at, it will make a circle. So here, if we look on the map, we know the eBee will circle the building. if we do this in manual mode, we'll just end up in a straight line, so that would be the main difference. But when you pilot, the feeling is almost the same in both modes. So finally, we are going to demonstrate some emergency maneuver. So let's start with the hold. So I just press the hold button, which is on the drone side. And now if we zoom on the map, we can see that the drone is performing the hold pattern. So I can use my finger to move it in the middle of this field. So when we are in hold, and the drone will just perform a small circle, so you can use it as a panic button. So every time you don't know what your eBee vision is doing, you can press hold and you know it will stop where it is and perform a circle. So here I will use the fact that we are in hold to perform some emergency maneuver, but we can do them at any moment. So let's start with the fast escape. So here, let's say we want to make a fast escape. We have the compass, it shows the direction of home, the wind direction. So let's say I want to escape north. I just hold the drone control joystick up, and we see now that the eBee vision is escaping, and we are going full speed in the north direction. I can change direction in flight, and it will go full speed. And as soon as I drop the joystick, it will start to just make a hold again. So let's go again, back into the middle of our field. And now we will demonstrate another feature, which is fast climb or fast descent. So to avoid collision in flight, you can always hold the secondary control joystick down. Now we see we are in fast descent, so if we look at the altitude, it's going down pretty fast. So let's go as low as possible. And now you can see the eBee vision has stopped by itself at 60 meters above the ground, and it will wait here. I can also see it on the map. We can do the same thing just by pushing the joystick up. And if we do this, we'll see we are now in a fast climb. So if we look at the altitude, it's rising extremely fast. So that's a good way to just gain altitude fast. But always remember that this is going to make some noise, and you probably don't want to do it unless you are forced to. So that covers the main safety features that you can use to get out of trouble situation. So before we land, we can also spend a few minutes to talk about connectivity. So here we could share what I see on the screen to other members of my team by using ATAK. We can also use a HDMI cable to send the image on another screen, and like this we can share in real time the information that the pilot is seeing, which is extremely useful in operations. So now we are ready to land. So just to do this, we just need to press go land, and eBee vision is going to land. So let's go into the map view. So the landing point is displayed as an L, and if I zoom, I can see the landing parameters. So first one is the wind map, which is displaying in real time in which direction we recommend to land. And then we have the base waypoint. If we zoom further, we see the likely touchdown area. So here we want to land on the road here. So let's just put my point on the road. I will just align the descent path on the road like this. And now we are ready for landing. So now we can see the eBee vision is waiting for clearance, which means it's waiting for me to confirm that we can land. So now that everything is ready, let's just confirm. And now the eBee vision will go down. At any time, I can press abort to just cancel the landing, or I can use the drone control joystick to make slight adjustment and push it right or left. And here we got a nice demonstration of the accuracy of the eBee vision landing. So it's right on the spot. We did not miss the road, and we can go and recover the drone. So as we can see, we have the green light, so it's ready to take off again. We just turn it off with a single press. And now we can go home and see what we've filmed.
So I hope everyone enjoyed that great overview that Jean-Christophe just provided, and hopefully it generates a lot of good questions at the end. We're going to continue to move on into the presentation, so thank you so much. So as you saw in the video, Jean-Christophe talked pretty extensively about some of the flight modes, right? So when we're thinking about how we're going to employ the eBee vision, it's important to kind of understand how you'll use these flight modes. So, you know, the flight plan mode kind of is the baseline of how you'll generate all of the additional flight modes, is how I look at it. So if you're going to plan your original flight plan and your waypoint modes, that's going to lead you to more target discovery of your area from a defense perspective. And then from a public safety or Fed Civ side, you're probably going to know your operational area quite well, since you're going to be very familiar with the area that you operate patrol in or potentially might have to respond to. So you can have a lot of these map points already kind of planned into your ground control station. So that kind of gives you flexibility to where you don't have to do that anymore once you arrive to the area. So you're just going to be able to immediately put the eBee vision into action with that flight plan mode, because you've already defined the areas it's going to fly normally. And then from a defense perspective, transitioning back, you know, we're going to identify a lot of these points ahead of time as well, just based on our knowledge of our operational area. So it's just going to give us a lot of target discovery options from that flight plan mode as kind of the basis of reference of how to get the eBee vision into operation. Now you can 100%, you know, kind of just put the aircraft in the air and then generate from there. But moving on to observe mode. So observe mode is going to let us discover things and then automatically tell the aircraft that I want to look at this continuously. And the aircraft is going to determine the best flight plan around that object or whatever you define on the geographical area to be able to continue to do persistent surveillance of that area. Once you're done there, you've collected your potential intelligence, right? You can then transition back to your flight plan mode. Or if something in that observed area continues to leave, that might be when I would transition to scout mode. So scouting mode, as we saw in the video, it lets you follow your basically defined point of interest, right? You're no longer flying the aircraft, you're now flying the camera system. Anywhere I'm pointing that camera system with that target identifier in the middle of the crosshairs is going to stay on that object, and you're going to continuously, you know, track that object. There are some AI developments and things out there that can do that manually, but what we've seen is that if the user is staying cursor on target, they have a bit better of control to continue to monitor that object, right? So if the object goes behind a tree or it goes behind a building that obscures it, sometimes that AI technology will lose it, but the manual operator will always be able to manipulate that sensor to stay on that interesting object that is moving currently in the scene. All of these flight modes are extremely, you know, enhancements of being able to collect pattern of life activity and things like that as you do target discovery in your area. Or if we're doing public safety, fire operations, things like that, it's going to let you generate a lot of freedom in your flight control plans and your mission planning to be able to kind of, you know, get that situational awareness, that intelligence that you normally wouldn't be able to get after if you did not have the capability of having an aircraft with this type of sensor and flight modes. So when we're talking about detection, recognition, identification capabilities, right? So this is a RGB sensor. The RGB sensor at 430 meters at 1.1 zoom. So you get quite a bit of activity in that scene, right? You can tell that there's kind of a building compound, there's some open terrain that's surrounding it, right? So it's automatically going to start leading me to my target discovery, or, you know, getting that situational awareness of my area. As I see things within this scene, if I want to continue to develop more pattern of life activity, that's when I can start using the zooming functions and some of the other flight modes that we talked about previously to start gathering even more situational awareness and building up that intelligence on my area. As we move in closer to the objective now, we can easily see, you know, a radio mast antenna. This potentially could be a communications platform, right? If this was a DoD-based scenario, or if I'm in a public safety oriented mission, you know, this might be a vertical obstruction I need to ignore, right? So now we can see that and kind of protect the aircraft from operating closer to that. It just gives us a lot of flexibility. So this is, once again, about 400 meters at 5.8 zoom. And, we're keeping the clarity of the sensor. I can easily see that there's kind of a soccer goal off there, to the right-hand side in the image. Wide open field, light poles, and once again, that communications mast right there next to that building compound. As we zoom in even further, as we're continuing to refine what we're trying to find, right? Like, let's say I was looking for entry points, exit points. I can see that there's a window here, there's a door. I can even, see the parking paint outlines that are on the asphalt, on this compound, right? So, as we, manipulate that sensor, kind of getting us the big picture scope as we get closer. Okay, let's refine it a little bit more. And then as you can see, the sensor zooms in and it still maintains that clarity. So I know we got to see it in the video a little bit, but as you transition the sensor into the zoom, there's no real hesitation, right? There's no real lag or feedback in the manipulation of the controls of the sensor. You get that automatic enhancement from, far wide scope view to immediately narrowing in to see the focus of like an entry point like we're seeing here. So the thermal capabilities of this drone are extremely important, right? So those of you that are attending today that have military backgrounds and experience, or those of you in public safety and law enforcement, a lot of things happen at night, right? I would say almost all, operations of high visibility happen at nighttime in the defense force or defense forces around the world. So it's important to have this thermal capability. So you see here some of the 700-meter distance, right? It is important to note that this is going to be a black hot, white hot thermal sensor FLIR based, right? So you're going to see the differences in temperature between the ambient environment. You will not see the actual temperature of the object. So we recently tested last week. I did a great training event with our VARs and some of our distributor networks. And one of them actually has night vision operation devices that we could borrow. And we were able to do a lot of nighttime training under nighttime conditions. And we were able to identify we had weapons on site as well, so we could see weapon profiles at night, and all of that stuff is extremely important when you're trying to conduct surveillance and reconnaissance of an area, especially one that's populated by people, to see potentially who has weapon profiles that they're carrying and things like that. We also were able to assemble under nighttime conditions as well. It's also important to know that these are going to be all geographically referenced images, right? So on your ground control station, as you fly and you're capturing these videos and these pictures, they're going to have, a small bit of metadata to the top left-hand side. That's going to be your MJS coordinate of the area, right? So once again, when we're talking about the interoperability and sharing the information that you're collecting, kind of using the ground control station as your briefing tool, you'll be able to reference the grid points of the images that you took, and pass that information along as you're gathering these intelligence profiles. Also, you'd be able to provide very accurate descriptions of the buildings and compounds of interest potentially, and also the things that we're seeing related to those compounds of interest as they break off. All of that just enhances your pattern of life development and collection abilities. And once again, focusing on the public safety side, we're going to be able to see potentially someone that's lost in an area, or some of the same things that kind of have crossover abilities in the defense and public safety law enforcement arenas as well. So let's talk about interoperability. So this one's important, right? So, modern warfare is never going to be a singular event, right? And I would even say for FedCiv or public safety law enforcement agencies, they're going to usually work with other people as well that are in those same verticals. So this information that we collect is great to be able to be housed at our level, but we need to be able to also potentially share it, right? So if we see something of extreme value, how do we get that through an architecture? How do we get that to be shared amongst multiple partners or multiple nations, right? So we have a couple of solutions for that. So Jean-Christophe obviously talked about ATAK as being a program of record for the US military, and most of our NATO partners around the world also use it as well. There are larger public safety and law enforcement agencies that are also invested in ATAK. But some other ways that we can share that data as well is through some of our radio solutions, right? So we have that HDMI output, we have the Nett Warrior connection ability in the GCS as well. So there are points of electronic shareability built into the GCS to be able to take that information, not only house it locally at the point of friction where you're using it, but also then take this information and make sure that we can share it with others as needed. So we have 3 antenna setups. So we have short, medium, and long range capabilities, right? So your standard loadout for the eBee Vision is the short range. That's what Jean-Christophe was flying in the video. That's just your antenna, the GCS, and the aircraft itself. That's going to provide you about up to 5 kilometers or 3.1 miles of range. So I'm actually currently down in California, and I was conducting a demonstration for the National Training Center, 11th ACR, who plays the operational force against the conventional units that come and train here. And I was actually able to fly in the standard configuration at about 4.7 miles from where I was located on that standard setup. So obviously 5 kilometer is kind of the base manufacturer range that we say it can operate to in that configuration, but we were able to test it past that capability. Moving on to the medium range setup. So this is going to give you about up to 15 kilometers of range or 9.3 miles. And then your long range setup is where we get the, super enhanced medium kind of range reconnaissance capabilities of 20 kilometers or 12.4 miles. So I like to share this slide, so we, as we designed and kind of, thought about how the eBee vision was going to fit into the landscape of other ISR platforms, right? So we really wanted to be that medium range reconnaissance aircraft. We wanted to be able to operate at past the max range of a quadcopter, and we wanted to kind of stay under the longer or the minimum range of a much more expensive, longer enduring aircraft, right? Like a Puma or something that's much larger and much more expensive. So we think that we've done a really good job in that 5 to 20 kilometer range, giving tactical end users a little bit more capability of range at their level, right? So quadcopters and larger platforms obviously serve a role in the ISR landscape. But there's kind of a dead zone that was built in, not intentionally, but yeah, we wanted to cover that middle ground in between to be able to give the tactical end user, once again, or public safety law enforcement folks, the ability to go out a little bit further as needed or directed from their location. So I think, hopefully everyone's enjoyed this, and I'm just certainly open to much, as many questions and answerings as possible. I hope that everyone enjoyed the video, and, please feel free to ask any questions that we can. I just did a lot of training these past 2 weeks, so there was a lot of good feedback from some of the customers and bars that we had. So hopefully some of that will feed this discussion as well as you ask your questions. So the GNS, Ildion asks, what happens if there's GNS spoofing or jamming, right? So there's user-defined safety settings to where if that happens, right? So you can define the time of the lack of response from the GNSS to the aircraft itself, or if there's jamming and the frequency cannot communicate. Once again, it's going to go into those return to home protocols that you've user-defined. It does. So once again, yes, when the GNS is jammed, you have that terrain data already loaded on your ground control station. So that's how the aircraft will return to home safely, because it already had that data in there. So it's its first mechanism to do once it's lost that GNSS for a specific period of time. Yeah, absolutely. So Kurt asked about some operations over people, right? So the ATAK was one of I think the first aircraft to be approved for operations over people, right? The eBee Vision has the same flight characteristics, weight, and dimensions as that platform. We are currently obviously going to be seeking some of the same certifications that the eBee TAK had, but you would have absolutely almost, I'm not going to say zero risk because there's never zero risk, right? But if you had an incident where this aircraft came down based on the same profile as the eBee TAK, there would be very limited damage to property or people based on some of the injury characteristic studies that are done based on weight profiles and aerospace dimensions and things like that. Pete asks, how does it handle in the wind? So that's a great question. So 17 meters per second, or about 29 knots. So one of our customers had a very high wind threshold requirement that we were able to meet with this platform because they were located in a coastal area where it was pretty windy. In addition to that, here at the National Training Center, for those of you who aren't familiar with it, it's basically in the Mojave Desert. There are very high winds here, basically almost yearly as well. So that was one of their requirements on the ground here as well, that it had a high wind threshold. Peter asked about additional payloads. So there are some roadmap stuff built in, right? But currently, right now, the only payload offered would be the FMV payload. Patrick asked, how can it be transported? So when you initially order the kit, you're going to get the IP67 Pelican case. That Pelican case is also inside it will be the backpack. So you would get kind of both options in combination. So you would either have the hard case, or you could externally remove the backpack that the system's contained in and then individually carry it that way. That backpack configuration, because might be a follow-on question, with everything inside of it would be about 22 pounds. So what is the accuracy? So I will talk about the accuracy of the system, right? So since it is GNSS enabled, those of you that are familiar with NATO targeting standard, it's going to be pretty close, right? But once again, it's not RTK enabled, so it's going to be a little less than the ATAK would be. For those of you that are DoD oriented, you would be able to tactically target off this, and I would not say strategically, however. Marius asked, what can be the maximum distance between a tablet and an antenna? So based on a cable configuration, it'd be, probably about 2 to 3 meters away from the controller, right? So the controller or the antenna comes in kind of a transport case as well, but it would just be based on the limitations of the cable. So you could kind of get creative if you needed to mount the antenna on a roof-based area or something like that. If you're trying to put it in your headquarters area, there's certainly room to be able to accomplish that load, that setup. Yeah, so it would be the same response either day or night for the GNSS jamming. Kyle asked, what is the sign level? So that's a great question. So we've done a lot of testing at the NTC here and then last week, and then I've obviously flown it extensively myself. So I would say once you clear about 100 to 150 meters, you're no longer going to hear the aircraft. And as we know that the world's a noisy place, especially combat operation environments or even potentially law enforcement and fire scenarios. So any background noise on the ground whatsoever, if there's a vehicle running or if there's a generator that's running, you're not going to be able to hear this aircraft operating overhead in any capacity. Also, too, it's extremely difficult to see. So the weather here at NTC this week was completely clear visibility, and you cannot see this thing. And this was not my saying this. This was the training of the end users that we had on the ground. They couldn't see it until it was on approach, and that's pretty close to your operational area at that point. So. This drone is purely for FMV collection. It does not have a surveying and mapping capability as of yet. Danny asked, what is the production volume capacity? So that would be completely, if we get a large order, our operations and production teams have protocols in place to be able to ramp up or kind of just, respond to that order within their own kind of SOPs and stuff like that for production. So we have a current tracking capability. So the current tracking system is that scouting mode. We are testing some AI integration on the ground control system that would be in the roadmap development phase. So Yuri asked once again, so the GNS thing, that's always quite a question. So you have terrain data built into your ground control station. So that's one of the things that you do ahead of your mission profile. So when it is GNS jammed, it's going to return to that point that it knew was already located into your ground control station. It basically continues to fly until GNSS does not persist. And if it continues, it's going to continue to, enact those safety protocols that are user defined. Do you have the terrain data downloaded on your ground control station? Ryan asked how much of it's repairable on the location. So that's a great question, right? So 90% of this aircraft can be repaired by the end user. It is high propylene styrofoam. So a lot of the problems can be fixed with either, electrical tape or the styrofoam glue that's provided in the kit. You can do all of the wing repairs, switch those out. You can switch out the propellers at your level. The only thing this aircraft would ever have to come back to us for would be a gimbal repair or the autopilot inside, basically the electronics that are built into the platform. And then the service, you'll get reminders on your ground control station. We're road mapping a feature that's going to let you know when to kind of do those services as needed. Yeah, absolutely. So we'll share the night vision videos because that was just kind of a rare opportunity. It's kind of hard to pull off because most manufacturers won't have access to night vision devices. I was kind of lucky to be able to get that for us. So yeah, I can certainly share those videos. What is the body made of? By Riaz. So I would say I flew the eBee ATAK quite a bit, and it's kind of the same landing characteristics. So it can take a hit. You know, if you have the option to land it in kind of an area that's not going to be as rough as, you know, like a grass or a field, obviously that's, you know, the most suitable. But it can certainly, as you know, Jean-Christophe demonstrated in the video, it landed on asphalt. I've landed it on concrete out here at the National Training Center in the Mojave Desert. I was landing it in the sand and gravel all week. So it can take a lot of, you know, sustained landings on austere or rugged terrain. Marius, do you have implementation stat? Yes, it is StatNag compatible. Great question. Can the ground control console control more than one drone, Chin? No, it cannot currently, but an interesting feature that it can do. So if you have multiple ground control stations within your inventory, you can kind of pass this aircraft along in sector. So let's say I was in, you know, team A and I conducted my surveillance of my area. I could then fly this to team B. I could disconnect from my ground control station and they could connect to it, land it if they needed to potentially switch out batteries or something like that, and then they could put it back up and continue to collect in their area. Solomon asks, could it be used for an airdrop, like dropping any information messages in a targeted area? So there is no payload capacity currently on this aircraft other than the sensor itself. James asks, does it have optical or digital? So it is digital. That's why it's so responsive when you zoom in. Kamal asks, is it not dangerous to land the drone on the road without any landing gear? You know, so there's a carbon fiber skid plate on the bottom of it, and it's meant to take those rough landings, right? So we understand that this product is going to be operating in some pretty remote, austere, rugged conditions. That's what it's designed to do. So, you know, that carbon fiber skid plate on the bottom is going to protect that aircraft tremendously in those scenarios. How much weight can it carry? Once again, there's no payload capacity for this aircraft other than the sensor. Mohammed, I'm trying to understand how much of the safety of this drone. Yeah, absolutely. So it's, once again, I think I talked to some of the operations over people constraints. You know, this drone could hit you from 300 feet. I'm not going to say you're going to walk away completely okay, but you're going to have very minimal injury and certainly no life risk at all in any capacity. Jose asked, do you have a plugin for ATAK or is it in the GCS? So the GCS comes with the ATAK stuff built into it. So it will publish your RTSP. So that's what you would need to be able to integrate into your ATAK server. So the accuracy of this drone, you're going to be within probably just out of RTK PPK accuracy, but once again, you're going to be, you know, within 3 to 5 meters potentially, probably. Because it's connected to a tremendous amount of satellites, so there's not going to be a lot of inaccurate as far as where your GPS coordinates are at, and then if you plotted those to see where they actually land on the geographic surface of the Earth. What does it mean, interoperability? Can you expand on that a bit? Absolutely, Ivan. So interoperability means that if I collect data in a standalone environment, I'm going to be able to take that data and share it through approved government architecture or approved architecture of wherever I'm operating it. So intelligence that just stays at the local level is not going to really solve a lot of problems, right? So I have to take that data and then put it into an architecture of interoperability that puts it out to other folks that can then discover it within that same network. So it's basically, you know, let's say I take a picture of a building, that's great, but I need to then take that picture of the building and share it through my network architecture to get it to other intelligence folks within that chain so they can then publish that out as well. And we have to have systems in place to be able to do that and have that interoperability. Do you provide API for third-party developed ground control station? Not currently. What will happen if the battery and the controller die before the drone does? Will it come back to the old location? Yes. So if any battery failures, anything happens like that, your safety mechanism is always going to be it's going to return to home. Can the video be broadcast to a control center located in a different place? Yes. So for on the Fed Civ side or law enforcement, that's not DoD based. Chromecast is an option, and also once again you have that USB-C output. But if your law enforcement or public safety organization does have ATAK, that is also another way to share it. Is the same landing as the eBee TAK, or do you have other types of landings? So the eBee Vision landing profile is extremely more refined. So the TAK was pretty good, but you had the steep and linear profiles. For the eBee Vision, I have landed this thing consistently in high winds, almost within a meter of where I'm standing. So it's improved accuracy from the landing. That was one of the things that they really kind of developed in the Vision, is the landing profile. It only does have the one singular type of landing, but it's extremely more accurate. Can you display the video transmission on a large screen? Yes, you can. Once again, that has that USB-C output, so you could do USB-C to HDMI, and you would have that visibility. We do this for demonstrations sometimes at large-scale events. All weather, so it's been rated to about 120 Fahrenheit. I don't know the other conversion to that, and then so once again to about 20 degrees below zero. So I can tell you, I flew this yesterday at National Training Center. It was 107 degrees, and we flew it all day long. Yeah, if there's lots of the technical questions, I certainly would encourage anyone to take a look at the white paper. You can download it, I'm pretty sure, from our website. Claudius, is there an integration between the eBee Vision and the other eBee systems like TAK? There is not. So they're kind of two different collection platforms. One is topographic data, and the other one's purely FMV. So I would say in a defense scenario, you can kind of use these as a tipping and queuing asset. What that means is that I would either fly the eBee TAK to gather high resolution topographic data. Let's see, I see something in that high resolution imagery that I want to now discover further. That's when I would send up the eBee Vision to go investigate that. What about nighttime operations? Should you know about the landing? So once again, I tested nighttime operations extensively last week. So there is one function. So you can turn the pitot tube off for the entire operation, right? So we're not giving out that light signature. But what I recommend you do to land it at nighttime is turn that pitot tube on. It gives you a little bit of visibility. We actually have a video captured that I'll make sure marketing has of when we turn the pitot tube on under night vision devices, and you can see it come on, and then the aircraft will land safely. If you log a coordinate of the target visibility observed, absolutely. So when you screen capture, that automatically is going to go to your gallery, and then you'll have those pictures there for reference. And once again, all of those pictures are metadata tagged with the MGRS coordinate that you captured. Maximum, Rob asked, what is the maximum flying altitude? So 16,000 AGL. I don't know if you would potentially ever need to fly that high with a reconnaissance aircraft that is a class 1 platform, but it has the ability to do so. Hano asked, what is the drone's IP rating? So light rain, GCS as well, same thing, light rain. Blue UAS, so eBee TAK is obviously, it was the first aircraft to do so. And for Blue UAS for the eBee Vision, I'm actually flying to New York on Monday to do the final testing flights with our R&D team for the Blue UAS program. So we expect that to be very shortly. Once again, I'd just like to thank everyone for their time today. I'd like to thank marketing once again for putting these together. I think it's a great way to kind of, get information out to the interested community. And we certainly look forward to your feedback and questions going forward. And once again, thank you all so much for your time. Enjoy your day.